Hi, welcome back to our last example for 6.4 arithmetic sequences. In this example, we're going to determine A and D, so that's our first term and our common difference, given two terms. It says in arithmetic sequence, the 11th term is 72 and the 21st term is 142. What is the value of the first term and the common difference? So we're going to solve this two different ways. We're first going to look at an algebraic approach. So I'm going to use the formula T of n equals A plus n minus 1 times D. That's like my general formula, my general explicit formula. I'm going to sub in the 11th term. So that's going to look like this. The 11th term is 72. I don't know the first value, but I know n is the term position, and that's 11. So I'm going to plug in 11 for n, and then times D. So I don't know the first term, and I don't know the common difference, but because of given this 11th term, I know the term value and the term position. That's what I plugged in here. Okay. So what we're going to do is we're going to expand D in. So first we know that this is just 10. So we're going to have 72 equals A plus 10D. Okay, we can't do anything else with this really at this point. I'm going to call this equation 1. Okay, so this here was using the 11th term. I'm just going to write that in here. We'll say sub in T11 equals 72. Okay. And now I'm going to repeat this, but for the next term. So we'll say sub in T21 equal to 142. So I'm just following this same formula here. So my Tn is going to be 142. So I'm going to write 142 equals. I don't know the first term. I just know n is 21. So I'm going to write 21 minus 1. 21 minus 1 is just 20. So we're going to rewrite this as A plus 20D. I'm going to call this equation 2. Okay. Now, what I would like to do is I would like to solve for A and D, and I can. I have two equations here. They both have the same two unknowns, A and D. So that's pretty easy to solve. You can do substitution or elimination. And because A's already isolated in both of these, I'm actually just going to do elimination. So I'm going to do 2 minus 1. So I'm going to copy out equation 1, place it underneath, like such. Okay, you want to make sure your variables line up. Okay, all the terms line up nice and evenly. And what I'm going to do is I'm going to subtract them. So my result is going to be 2 minus 1. So 142 minus 72, that's easy, that's just 70. What's A minus A? Well, nothing, the A's cancel out, so we get 0. So I'm not going to write a 0 here because it's just 0, there's no point. 20D minus 10D is going to be 10D. Okay, so this minus this gives me that. Okay, and now this is really easy. Divide both sides by 10. And we got D equal to 7. All right, now we want to solve for A. Well, we can sub D equals 7 into any equation. I'm just going to pick one. So we have 72 equals A plus 10 times D, and D is 7. So 72 equals A plus 70, therefore A equals 2. All right, so that's an algebraic approach to solving for the first term and the common difference. So you might have already thought of this. Maybe when you read the question, you're like, okay, that's actually not too hard. I don't really need to do all this. If I know this is the 11th term and this is the 21st term, then these are 10 apart. So we'll say, or, this is like an intuitive approach, I'll say. So term 21 and term 11 are 10 terms apart. So we know there's a gap basically between this number and this number of 10 terms. So what's the common difference? Well, basically D was added 10 times to go from here to here. So we can say this means the common difference must have been added 10 times to go from 21st term is 72. Sorry, the 11th term is 72 to the 21st term, which is 142. Okay, so we can kind of do this. We could say T21 minus T11 equals 10 times D. Okay, so to go from the 11th term to the 21st term, the common difference had to be added 10 times. So if I subtract those terms, I know it has to equal 10 times the common difference. So we have 142 minus 72 equals 10 times D. And you kind of might think this is a bit familiar now. 142 minus 72 is just 70. Divide both sides by 10. And we got D equal to 7. So this is just a different way of looking at the question. But notice the math is still the same, because that actually shows up right here when I do elimination. The algebraic approach, I had to do 142 minus 72, which gave me 70. And then when I subtract these, I get 10D. So it still actually is the same math. It's just a different perspective or a different way of looking at the problem. Now that we know the common difference is 7, we could work backwards. T11 equals 72. So if I wanted to know what T1 was, the first term, I would have to go down 10 common differences. So this decreases by the common difference 10 times. So since D is 7, this has to go down 70. So T1 would need to be equal to just 2. Kind of backtracking. So to go from the 11th term to the 10th term, we have to go backwards 10 times. 10 times we need to subtract the common difference. Okay, so that's it for the last example for this lesson. Hope you guys found these helpful. The homework's already posted, so you'll be able to start that soon. Okay, I'll see you in the next lesson.